So in the last video, we talked about 3 different types of symmetry, and I gave you the tests. Those are the tests for functions, testing for symmetry, but they give you another idea here that might be a little bit easier to wrap your mind around. So if you want to know if something's symmetric about the y-axis, replace x with the opposite of x. And if it doesn't change, then the answer is yes. The answer is yes. It's symmetric about the y-axis. Okay, so if you want to know for the x-axis, you replace y with the opposite of y. And if it doesn't change, then the answer is yes. Okay, that's a weird word change there. And then if you want to know if it's symmetric with respect to the origin, you replace both of them. So you replace x with negative x and y with negative y. And if it doesn't change, meaning the equation doesn't change, then the answer is yes. Now you can have a relation that's symmetric about all 3. So sometimes it might be just symmetric about the origin, or it might be symmetric about the y-axis, but we can have relations that are symmetric about all 3 or 2 of the 3. Okay, determine if the function is symmetric with respect to the y-axis. So for the y-axis, we're going to take our equation and we're going to plug in negative x. Whoops, forgot the negative on the x. Okay, there it is. Okay, so when we work that out, we get negative x equals y squared minus 1. How do we know if that's the same as the original equation? Well, one way that is useful to deal with this is multiply both sides by negative 1 and see what you get. You get x equals negative y squared plus 1. That's not the same, so no, it is not symmetric with respect to the y-axis. Okay, now for the x-axis. You plug in the opposite of y. And you get x equals y squared, oops, that's supposed to be an x. X equals y squared minus 1. Well, that is the same as the original, so yes, it is symmetric with respect to the x-axis, yes. Okay, now we're going to try the origin. So with the origin, we replace both of them with the opposite of x and then the opposite of y. So we get negative x equals y squared minus 1. If I multiply both sides by a negative 1 to get that x to look the same, I get x equals negative y squared plus 1. Is that the same as the original? No, it's not. So, no, it's not symmetric with respect to the origin. All right, let's try the next one. Same thing, y-axis. So you plug in the opposite of x. And you get y equals negative x cubed. Is that the same as what we started with? No. So it's not symmetric with respect to the y-axis. Let's try the x-axis. So we're putting in the opposite of y equals x cubed. Now, is that the same thing? Well, you're probably saying no, obviously it's not the same thing. But to get the y the same, multiply both sides by negative 1, and then you're going to have y equals negative x cubed. So no, that's not the same thing as what we started with, so no. Okay, now what about the origin? So I'm putting in negative y and I'm putting in negative x for x, and I get negative y equals negative x cubed. But this time, when I multiply both sides by negative 1, what's going to happen? I'm going to get y equals x cubed. And then is that the same as what we started with? Yes. So it is symmetric with respect to the origin.